Dear students, welcome to Tungal online classes. So, in the last video, we discussed the types of some types of connective tissue. I had started with connective tissue in that loose connective tissue is one type, and that includes areolar tissue, adipose tissue. How is the structure of areolar tissue and what are the functions of areolar tissue, right? As well as how is the structure of the adipose tissue, what is the major function of adipose tissue that we saw in the last video. So now in this video, let us start with the skeletal tissue. It is the second major type of the connective tissue, right? So let us start with that. Skeletal tissue. As the name suggests, this forms the skeleton, that is endoskeleton system of the vertebrates, right? So this tissue, it forms the endoskeleton of vertebrates, right? So it forms the endoskeleton of the vertebrates. So what is the major function of this endoskeleton? What it is made up of? What are the types of skeletal tissue? So let us see one by one. See here skeletal tissue, it is forming the endoskeleton so that it gives support as well as protection to some internal smooth or delicate organ itself. So this tissue gives support and protection to some of the internal organs. Some of the smooth internal organs are there, as well as very delicate organs are there in our body, and all are supported by this skeletal tissue itself, right? And it also provides a hard surface for the attachment of the muscles, right? As you know, the tendons. What are tendons? So these are the fibers which attaches to the bones, right? So tendons, you know it better, right? So it gives hard surface for the attachment of the muscles. It gives hard surface for the attachment of muscles, right? So this is more important aspect to be remembered, right? So next one, it also help in the manufacture of the blood cells, right? It also help in manufacture of blood cells, right? It helps in manufacture of the blood cells, right? So say for example RBCs as well as WBCs, such kind of the blood cells are synthesized over here, they have been produced over here, so right? So that's why it helps in manufacture of blood cells, and it also helps in storage of calcium as well as phosphorus itself, right? Calcium as well as phosphorus are stored in this skeletal tissue. Example, bone is there. In bone, phosphorus as well as calcium is densely stored over there, right? So that's why it acts as the storage of calcium as well as phosphorus. So this is also one more important thing related with what? Skeletal tissue. And next, it is of two types. Skeletal tissue is of two types. One skeletal tissue is cartilage, and second one is bone. So this way, there are two types of the skeletal tissues that we come across. First one is cartilage tissue. Cartilage tissue, right? So what is this cartilage tissue? How it is in structure and what is its function? Let us see. So cartilaginous tissue, it is a kind of a smooth, right? It is a kind of a smooth, semi-rigid, tough, right? Tissue itself, right? It is tough, semi-rigid. It is tough, semi-rigid tissue. That is skeletal tissue. Semi-rigid skeletal tissue. Right? It is a tough, semi-rigid skeletal tissue. Right? And it is found in right? Young ones mainly. It is found in young ones mainly. It is found in young ones mainly. Means in children it is vastly provided, right? So and much of that cartilaginous tissue is converted into bony tissue. So right. So in others, much of cartilage is converted into bony tissue. Much of the cartilaginous tissue is converted into bony tissue, right? In adults. And where actually this cartilaginous tissue is occurrence. Where it is occurring? So at the tip of the nerves and ear pinnas and in the C-shaped rings that we come across, in those C-shaped rings, cartilaginous rings they are in trachea, and they are also present in the bones, that is vertebrae of vertebral column. There also they are present. And this cartilaginous tissue makes the eustachian canal that connect between the throat as well as the mid-ear, right? So all these are the reasons where this tissue is available. Let us list out all of them. So first one, it is present in eustachian canal. It is present in eustachian canal. It is present in vertebrae of vertebral column. Means so in the bones of our vertebral column, and it is also present in trachea. Right? It is present in trachea, and it is also present in larynx. It is also present in larynx at the tip of the nose, ear pinna. Right? In such regions, usually this skeletal tissue, that is cartilaginous tissue, is occurring. Right? So this is the occurrence. Right? And this cartilage is once again classified into three types of cartilaginous tissue. So number one, what is the first cartilaginous tissue? It is already during classification we have already studied them, right? First one is, you refer that classification, hyaline cartilage, and second one is fibrous cartilage, and third one is calcified cartilage. This is how we are going to classify this cartilaginous tissue into three major types. So all those types will study in detailed manner one by one now. Yes, first one is hyaline cartilage. This is hyaline cartilage also. So how is the structure of this hyaline cartilage and where it is present, means a location, everything, let us see now. So first of all, skeletal tissue, that is hyaline cartilage. Hyaline cartilage. This is the first kind of cartilage, right? So it occurs, means its a location, first of all, right here. It is usually present in the nasal septum. It is present in the nasal septum, where the septa is present, right? Nasal septum, and it is called, it is present in the larynx. It is present in the larynx and between the ribs and the sternum. Right? Between the ribs and sternum. Here the ribs that we come across. Here is the chest bone called as sternum is there, and that sternum attaches to the ribs. In between these two, there one cartilaginous tissue, that is hyaline cartilage, is there. Right? So there it is present. Right? In the same way, in several regions it is present. And this kind of hyaline cartilage is tough, semi-rigid, avascular cartilage tissue. Why it is called as avascular? Of course it is tough, rigid, semi-rigid, of course. Avascular means that, so there, this tissue is not at all provided with any blood vessels or blood supplies. There is no blood supply. No blood supply. There is no blood supply at all in this one. So that is very important point to be noted over here. So how the blood supply is given to this tissue also. So later we will see during the study of the structures. Right? And this hyaline cartilage is so glassy, translucent and glassy in nature. So this is more important aspect to be remembered. It is white, translucent and glassy in nature. Just like glass it is present. It is a transparent one. Right? That kind of translucent glassy tissue this hyaline cartilage is. Alright? So this is the nature of this hyaline cartilage. Right? And it is characterized by the presence of what? The chondrocytes. So what these cells are called as chondrocytes. And so it also consisting of the lacunae. What it is? Lacunae. Right? And it is characterized by the pericardium. Right? That is also very important. So here itself. Right? Mainly in the matrix of this tissue, what are actually present are, so chondrocytes are there and lacunae are there, and even the presence of some of the fibers also. Okay, but you are not seeing here fibers. Why? I will explain that, right? So it is characterized by, it is characterized by the presence of, what? Lacunae are there, chondrocytes are there, and even the matrix cord as chondrine is also there, and perichondrium, this is also a very important aspect in this highly cartilage. So it is characterized by the presence of lacunae, chondrocytes, matrix, as well as chondrine, matrix cord as chondrine, as well as perichondrium. Alright, so these are the structures mainly present over here in this type of tissue. Alright, so let us see the matrix. In the matrix, so what are present? Chondrocytes are there, along with that one some fibers are also there. Fibers like white collagen fiber as well as yellow elastic fibers. So these are the two types of fibers that we come across in this tissue also. But these fibers are invisible. These fibers are invisible. They are not so visible to our eyes. Why they are not visible to our eyes? Is because the refractive index of these fibers as well as the refractive index of the matrix is similar in this tissue. That's why they are invisible. Why they are invisible? Because the refractive index of fibers as well as matrix is same. Very important point to be noted over here, right? So that is nothing but the refractive index of the fibers as well as matrix. So both are similar, that's why they are invisible in nature. Next important point is chondroblasts. This point is very important. What they are? Chondroblasts. What is chondroblasts? So these are the specialized cells present inside the, right? So chondroblasts are specialized cells present inside the lacunae. So these are present inside the spaces in the matrix called lacunae. Want to be noted. So inside the lacunae, there some type of cells are present, and those cells are called as what? Chondroblasts. The point is very important, right? So these chondroblasts, they secrete chondrine. What is the secrete? They secrete chondrine. What is chondrine? Chondrine is nothing but it is the matrix. What is chondrine? Chondrine is nothing but it is the matrix, right? So this matrix is secreted by the chondroblasts. After the secretion, these chondroblasts, so they become metabolically inactive. So whenever they become metabolically inactive, that moment what happens? They are converted into chondrocytes. So they become chondrocytes later, right? This point is very important point to be noted here. So what are chondroblasts? They are specialized cells present inside the spaces as a actinic, and these chondroplasts secrete the chondrin, that is nothing but matrix, and these become, after secretion, these become metabolically inactive and they become chondrocytes. So very important point to be noted here. Whenever the chondrocytes are formed, that moment these chondrocytes are in need of the food or the nutrients. So they are in need of food or the nutrients, and even they are in need of oxygen supply, and even they need to excrete. So the waste products, excrete the waste products during metabolism, right? All these activities are too essential for these chondrocytes which are present. So here itself in this tissue, but this tissue already I have mentioned they are so avascular in nature. Avascular in the sense that this tissue is not at all provided with the blood supply. Am I right? So then which tissue is going to provide this one the blood supply for getting the nutrients as well as oxygen as well as excrete? See here, this tissue is surrounded by specialized structure called as perichondrium. Right? So perichondrium is there. So this perichondrium that provides this specialized tissue that provides blood supply. Why? Because blood vessels are present in the perichondrium. Right? And note down the point. See here, chondrocytes means this tissue is surrounded by what it is surrounded by? It is surrounded by a specialized structure called as perichondrium. Right? It is surrounded by the perichondrium. This perichondrium is supplied with the blood vessels. What are present here? Blood vessels are there, and these blood vessels they provide all these requirements, right? So they provide what? The food, nutrition to all these chondrocytes what they are in need of, and they supply oxygen level, and they excrete, so they can excrete the waste products to these blood vessels. Right? So this is how perichondrium which surrounds this tissue so would help for nutrition as well as oxygen supply, etc. Right? The point to be noted. So it is a very important point related with this hyaline cartilage. Right? After this one, location we came to know where actually this is available and what is the function it gives. Right? So it gives first function. What is the first function? So it gives flexible support to the tissue, or it gives flexible support to the body. Right? So this is more important aspect, and it avoids the friction. Between the bones. Why? Because it is also present in the articular surfaces of the bones. Articular surfaces are later I can explain the structure of bone. That moment articular surface I will explain there. So in between the bones, two bones, so there is a gap. In that gap, this hyaline cartilage is present, and it avoids the friction between both the bones. Right? So these are the major functions of this hyaline cartilage. So this is about the hyaline cartilage. And later one is fibrous cartilage, and next one is calcified cartilage. Let us see now. Second one is fibrous cartilage. So this is a little less firm than hyaline cartilage. It is less firm than that of the hyaline cartilage. So and this is having great strength. It has great strength. And this fibrous cartilage, as the name suggests, it is rich in fibers. It is rich in fibers. And what kind of fibers? That is white collagen fibers, as well as yellow elastic fibers. So like this, there are two types of fibers are richly provided in fibrous cartilaginous tissue, right? And this fibrous cartilage, as already we have classified it into two types of fibrous cartilage. So based on the type of the fibers present in themselves respectively, and the first one is white fibrous cartilage, white fibrous cartilage, and second one is yellow elastic cartilage, right? So these are the two types of cartilage so that we come across in a fibrous cartilage. So and white fibrous cartilage, it is a one kind of cartilage in which so white fibers are rich in number, right? As we can see this one diagrammatically, okay. So here you will come across all the white fibers which are arranged parallelly, right? So like this. See here, all these are the white collagen fibers. These are all white collagen fibers which are parallelly arranged in this tissue, and they are abundant in number, means they are more in number. So these are more in number, but yellow fibers are not abundantly available in this one. So these are nothing but chondrocytes. These are nothing but white fibers. This is nothing but see here, this is chondrin. That is nothing but matrix. Okay, this is chondrin. And perichondrium is absent in this case, right? It is also just like this tissue is also just like the hyaline cartilage, but it is rich in white collagen fibers. These are nothing but so white collagen fibers. They are abundantly available, and these are nothing but chondrocytes, right? So this is how the structure of the white fibrous cartilage. And second one is yellow elastic cartilage. So here perichondrium is absent. Point to be noted. And We'll finish the occurrence also. So it is available in pubic symphysis. So it is available in pubic symphysis, and it is also available in intervertebral. So discs, an intervertebral disc. So this is available. White fibrous cartilage is available. It is less firm than that of hyaline. So it is similar to hyaline, but it has abundant number of white fibers. So fibers. So that is the important thing, and perichondrium is absent over here. And these are the unique features of what? White fibrous tissue. Yellow elastic cartilage. It is also similar to the hyaline cartilage, but only the exceptional thing is it is rich in yellow fibers. It is rich in yellow fibers. Yellow fibers are abundantly present over here. So this kind of tissue is known as what? So that is yellow fibrous tissue. See here. So these are thick. So these are thick in nature. This kind of yellow fibers are rich in number. And here and there, what are present over here? The chondrocytes are present. And remaining one is chondrin. Chondrin is nothing but it is the matrix. This is matrix. The important point is noted over here. Yellow elastic fibers are in number. It is highly flexible in nature. It is highly flexible and it shows elasticity. The main function of this tissue is elasticity. Say for example, it is present in ear pinna. Ear pinna are highly flexible. They are elastic in nature. And the tip of the nose, it is also same. Right? Here this what is present? This yellow fibrous tissue is present. So note down the point, occurrence of this tissue. Occurrence. Where it is occurring? At the tip of nerves, and it is present in the ear pinna. It is present in ear pinna as well as at the tip of the nose, and even it is present in epiglottis. Epiglottis, larynx, like this. So this yellow fibrous tissue is present over there. And one more point is there. So that is calcified one. Okay. Third one, that is calciform. There are three kinds of them. So white fibrous cartilage and yellow elastic cartilage, calcified cartilage. So as we can see the structure of this calcified, it is similar to just like the hyaline cartilage, but the only difference is there the deposition of the calcium salts that you come across in this tissue, right? Deposition of calcium salts in this tissue, right? So that is why this tissue becomes very hard, right? So hard as well as rigid in nature. So because of this calcium ions or calcium salts, right? So this kind of tissue usually present in the vertebrae of the shark. So they are present in the vertebrae of shark. So there it is very hard and rigid. The structure is very hard and rigid. So this is how we classify this fibrous cartilage into three kinds. One is white, yellow, as well as calcified cartilage, right? So after this one, next one is bony tissue, right? So how is the structure of this bone? What are its functions, right? Let us see the detailed structure of bone now itself. Okay, next tissue is bone tissue, that is bone. Already you know the endoskeletal system of different kinds of the vertebrates is made up of cartilaginous tissue as well as bony tissue, right? So now let us start with the next tissue. So that is bone. What is this bone tissue? So let us see. So it is very hardest. It is very hardest tissue in our body, right? So and this tissue makes the endoskeletal system of many number of the vertebrates, right? The point we noted here, it is hardest tissue in our body, and it makes the endoskeletal tissue. It makes the endoskeletal tissue or endoskeletal system in vertebrates. Especially, right? So that kind of a very hard structure, that is bone. So bone is responsible for what? Already I have mentioned this point. So this bony tissue itself is responsible for the storage of calcium as well as phosphorus, salts, right? And along with these one, it also helps in production of the blood cells, right? So it helps in storage of calcium and phosphorus, and it gives one more point. It gives mechanical support to body, and also help in the production of the blood cells like RBCs, WBCs, right? So in bone marrow itself, right? As you know it better. So this is the major functions of this bone, and this microscopic structure of bone. Before going to see that one, let us see the macroscopic structure of the bone first. So the macroscopic structure of the bone. So long bones usually we prefer to study over here. So this macroscopic structure mainly consisting of some of the parts in that one. So what are those one? So periosteum is the first part, endosteum is the second part, and bone marrow is the third part. So these are the three major parts that we come across in one mammalian bone. So let us draw the diagram of this mammalian bone. See here, this is how the mammalian bone is there, and at this region you must be aware of this structure. This is the end portion of the bone, separately all these structures. Okay. So here is the central axis of the bone. That contains bone marrow. Alright. So like this is how the structure of bone is usually. Right. So let us start with the first part. So that is periosteum. As the name suggests, peri means at the peripheral region. See here, this region, the peripheral region. Consider this is the peripheral region. In this peripheral region, there you come across white fibrous sheath. What you come across? White fibrous sheath. And this white fibrous sheath, which uncovers this bone externally, and that is called as periosteum. What it is known as? Periosteum. Ostia means bone. So the peripheral part of the bone itself is called as periosteum. So I hope it is very clear to you. Right? And this layer plays very important role. So that is why? Because it provides nutrition for the bone cells, right? And it also provides the blood supply, right? So over here, and it also helps in repair of the bones. It also helps in the repair of the bones itself, right? So this is periosteum. It is the external part. So external sheath it is, which uncovers the long elongated bones in mammalia, especially mammals also, right? So this is periosteum it is called as. And this periosteum is followed by the endosteum. So in that endosteum, so before that we must know the matrix. What actually the matrix of this bone consisting of? So the matrix mainly consisting of a specialized protein. Here I write matrix mainly consisting of a specialized protein over here, and that protein is ossein. What it is known as? Ossein is the name of the protein which makes the matrix of this one. And along with this protein, so one more thing is also there. What is that? White fibrous tissue is also available, right? White fibrous tissue is there. Ossein is the protein present in that matrix. After the matrix, you come to the endosteum. What is that? Endosteum. So as the name suggests, inside the bone. So you come this side, up to the central axis. This endosteum mainly consisting of the white fibrous tissue. Along with that one, you will come across bone forming cells also. Very important point to be noted. So bone forming cells are also present over here in endosteum that forms the bone, and those are endosteum, right? So bone forming cells, these are osteocytes, so are also present over here in endosteum, right? So this is endosteum. Apart from this one, there we come across, there is a cavity at the central axis. And that cavity is called as what? bone marrow. What it is known as bone marrow. See here, bone marrow. So that is medullary cavity it is called as. Right? It is called as medullary cavity. It is completely filled with a fluid called as what? Bone marrow itself. What it is completely filled with? Bone marrow. See here, bone marrow is of two types. It is of two types. So sometimes it is red bone marrow and yellow bone marrow. So like this, there are two types of bone marrow that we come across. One is yellow bone marrow and second one is red bone marrow. In young ones, that is in children, so most of the bone marrow is always red one, right? Red bone marrow is available in, so children, it is available in children, right? Completely it is present. Okay, so then what about this yellow bone marrow? So yellow bone marrow, as the age passes, so in adults 50% of the red bone marrow is there, remaining 50% is yellow bone marrow is there. So like this, as the age passes, so this red bone marrow converts itself into yellow bone marrow, and this yellow bone marrow, which is rich in fat, and this red bone marrow, which is present in children or in adults, it helps in the production of RBCs as well as WBCs. That is produced by the red bone marrow. So like this, so there are two types of bone marrow that we come across. So the red bone marrow converted itself into yellow bone marrow. Okay, so this is about what? Bone marrow. And so in the from this one, let us see. The central axis of the bone itself is called as a diaphysis. What it is known as diaphysis. It is called as diaphysis, right? The central axis of the bone is known as diaphysis. So this is dense compact bone, it is said. What I will say to this? Dense compact bone, the central axis. Okay, and the broader end of this bone, right? So this broader end of this bone is called as what? Metaphysis. The broader end of this bone is called as metaphysis. Broader end of the bone is called as metaphysis. And above this metaphysis, the bone is further capped, right? So the cap above the terminal broad structure is called as epiphysis. Epiphysis. What it is known as epiphysis. And whenever it is capped, so there you come across one junction between the broader end of this bone as well as the epiphysis, that is cap on this bone. So that junction between these two, that forms epiphyseal plate. What it forms? Epiphyseal plate. It forms the epiphyseal plate. And so this epiphyseal plate, above which there you come across articular surface of the bone. Articular surface. So that is made up of a cartilage. Already I have mentioned articular surface of the bone. I had mentioned where it is. I will show whenever I will explain the bone. I had reminded you there itself. So that's why. So this is articular surface the cartilaginous tissue, right? So this cartilaginous tissue, what we have, that avoids the friction between two bones, right? So that is very important aspect to be remembered. And this structure, broader structure, that is epiphyseal plate, what we come across, it has one important function. So epiphyseal plate has one important function, that is nothing but epiphyseal plate helps in elongation of the bone, right? So children will be small and they have very small bone, and most of the bones are in cartilaginous form. Later they are converted into bone forms, right? And that bone enlarges when the growth occurs. So during the growth period of the human being, so that increases because of this epiphyseal plate, right? So that is nothing but it is the junction between epiphysis as well as the metaphysis. This is how the macroscopic structure of the bone is, right? So afterwards, let us start with means in the next video we will study in detailed manner so the microscopic structure of this bone. Means in microscopic structure there we come across the bone forming cells, that is osteocytes, that we come across how they are, where they are. They are also lying in the lacunae. What are lacunae? They are the spaces inside which the osteocytes are lying, right? So that structure, so mammalian structure is Haversian canal system. It is said to be as so mammalian bone system. How microscopically it looks to be such kind of many Haversian canals together form this entire bone structure. So the detailed study of the microscopic study of this bone will do in the next video. Thank you.